find out the limit of a to the power n plus b to the power n to the power of 1 over n as n approaches infinity, where a is larger than or equal to 0, which is less than or equal to b. And when we first were given this type of question, we wonder, where do we even begin? How do we even approach this type of questions? And so this is what I found using a calculator. So I cheated a little bit. So when I input a equals 2, b equals 3, and input n equals 10, and increasingly get larger and larger. So this is what I found. So as n gets very large, we can see the overall outcome gets closer and closer to 3. So that's a strong indicator that our limit is probably b, even though this is not a proof by any means. But it is still a very useful hint. Now, pretend we don't know the limit is b. Right? When we first approach this type of questions, we ask ourselves, we only wish that there was only a to the power n inside the bracket. So therefore, we can simply get a to the power n raised to the power 1 over n, which will give us a. And we also wish there was only b to the power n inside. Therefore, we simply get answer of b as an overall outcome. Right? But eventually we don't know whether the limit is a or b. Right? Since now we see there is inequality relation, that motivates us to perhaps we can use squeeze theorem if we use it properly. Right? Especially when we lose the inequality. Now, what if I try to loosen the inequality by shrinking the inequality a little bit? Let's copy it down. A to the power n plus b to the power n raised to the power of 1 over n. I want to shrink it a little bit to the left-hand side. I want to see whether it is larger than or equal to some other quantity. Make it smaller. So how can I make it smaller? Maybe I can just simply get rid of b to the power of n, because b is already larger than or equal to 0. So simply get rid of that. So we're left with a to the power of n to the power of 1 over n. That is essentially a. Now on this right-hand side, how can I make it larger? Can I just replace b to the power of n by a to the power of n? Perhaps not. Why? Because a is less than or equal to b. Right? If I replace b to the power n with a to the power n, it'll become smaller, not larger. Right? So the only way for me is to maybe, let's see if we can replace b to the power n by twice of a to the power n. How about that? I say, still not possible. Why? Because we don't even know if twice of a to the power n is greater than b to the power n. We don't know that. Because b could be way larger than a. Right? We don't know. So in that case, we cannot simply replace b to the power n with anything that's related to a to the power n. Right? But what we could do is we could replace a to the power n with b to the power n. That way we can make it a little bit larger, right? So that becomes twice of b to the power of n raised to the power of 1 over n. And that is equal to 2 to the power of 1 over n times b. And obviously any constant raised to the power of 1 over n, as I mentioned in previous videos, obviously approaches 1. So that is approaching to b. So in that case, in fact, we cannot apply the squeeze theorem because we have different limits on both sides. Right? So it is unsqueezable in this case. So how about so this is a failure, but how how do we like, what if we want to say a to the power n plus b to the power n? Let's just tweak it a little bit. How about instead of replacing here, we just simply get rid of b to the power n, right? Instead of doing that, how about we just get rid of a to the power of n and only left with b to the power of n to the power of 1 over n, right? Also made smaller, right? That is equal to b. And very often there is no guarantee that we succeed the first try, so it's okay. We just gave it multiple tries, right? So this is smaller than or equal to. How can we make it larger, a little bit larger, by replacing this term a to the power n by b to the power n, right? Because a is less than b, b is greater than or equal to a, so it's okay. So b to the power n twice of b to the power n over to the power of 1 over n. So I forgot to put 1 to the power of 1 over n on here. Forgot that. So this is equal to, again, 2 to the power of 1 over n times b. So on this side, as I mentioned, this term easily approaches 1, and this easily approaches b as n approaches infinity. So, right, in this case, we actually have exactly the same limit on both sides. So in this case, we can apply the squeeze theorem and say, really the limit of that quantity really is b. Just like our calculator indicated, right? Here we choose 3 as our b, right? So obviously approaching 3. So intuitively it makes perfect sense. So that is b. And for those of you who watched a previous video of mine, you probably realize that this is actually a discrete version of a previous continuous version of a similar type of question, which looks like something like this. The limit of n approaches infinity. Quantity to the power of 1 over n. Inside quantity, I have the integral from a to b. F raised to the power of n of x dx. This limit, right? So this is actually a continuous version of this discrete version. Like if I remember correctly, given that f is continuous. Also, f is non-negative. If I remember correctly, non-negative. Then therefore we've concluded that this limit is equal to the maximum of, so equal to the maximum of f of x, where x is over this AB interval. That's the maximum value of the functional value over this interval, right? So in this discrete version case, we have b is our maximum value. B is the bigger one out of those two numbers, right? So in our continuous version, we say the maximum value of the functional value over this interval, right? Interesting fact. And in a next video, I will prove a generalized case of this case where we have a1 to the power of n plus a2 to the power of n plus all the way up to am to the power n, where n is a fixed positive integer, to the power of 1 over n. I want to find out this limit as n approaches infinity in next video.